All right, welcome to this training. My name's Carl Sugart, and in today's video, we're going to be going over all of the AI beginner lessons. This is a really good starting point for a lot of people. You should have found us at CodeVibin.com. If you haven't, I would head on over there to get access to more training like this one. We're going to go ahead and get this kicked off because we have a lot of deep dive information to get into. A lot of this stuff too, by the way, doesn't necessarily apply to what you're currently thinking you're going to do, but I still highly recommend that you go through it because it's going to help you understand how AI actually works, and you're going to have more critical thought and thinking mechanisms in your own mind to help you understand how this works. And the other thing I want to read to you about this is that your mind has neurons and your mind has little flashes of thoughts, and the way your brain works is very interesting, and we're learning a lot more about this as things continue to go on. But you're going to actually see some similarities between how your brain works and how AI actually works, and how scientific ways that they've broken things down so you could learn them, for one, but for two, to understand what's happening in the back end. So when you get on ChatGPT, or you get on Claude, or you get on Gronk, or you get on Gemini, or any of the large ones, Perplexity, you're actually going to have an idea of what's happening in the background when you ask it a question. And also, this will help give you a further futuristic or future way to work directly with LLMs, because you're going to understand how they actually work. So let's get into it. This is AI for beginners, understanding artificial intelligence from the ground up. Okay, so we're going to go into everything here, guys. Artificial intelligence is the simulation of human intelligence processed by machines, especially computer systems. It enables computers to perform tasks and typically requires human intelligence. Interesting thing, right? You're like, oh, it's the AI. They're the one using all of their minds. Not necessarily. It still takes an operator to use it. It's not like it's just going to magically be able to talk to you in ESP or anything like that. You're going to have to actually interact with it. You're going to have to tell it what you want. And it's, to me, it's like a genie in a bottle. You rub the bottle and you tell the bottle, you ask the genie, this is what I want. And the genie says, your wish is my command, but you have unlimited wishes. And if you know how to use it, you're going to get a lot further with it. So what we'll be talking about too is like learning, acquiring information, and rules for using it, reasoning, using rules to reach conclusions and make decisions, problem solving, finding solutions to complex challenges, and perception, understanding and interpreting sensory information. So the AI family tree, this is basically the three different types of AI that's happening in the background. You've got artificial intelligence, we've got machine learning, and we've got deep learning. And so we'll break those down. But artificial intelligence is the broadest concept. Machine learning is the subset of AI that learns from data, and deep learning is a specialized subset of machine learning using neural networks and multiple layers. Machine learning is a subset of AI that enables computers to learn from data and improve their performance without being explicitly programmed for every task. Data-driven learns patterns from examples rather than following fixed rules. Adaptive improves performance as it processes more data. Pattern recognition discovers hidden relationships in complex data sets. Predictive makes decisions and predictions based on learned patterns. So very interesting thing, a lot of pattern recognition here. It's really the way your mind works on each of these things. It takes raw data, processes that data, gets some models around that data, then uses some past information it's learned, so some trained model, and then comes up with those actual predictions after that. And that's basically the interface where you're interfacing with it. So when you're interfacing with it, you bring in the data here, and when it comes through this 3 steps here, it's going to come back to you with those predictions if it doesn't know. So some of it is predictive. A lot of it is. Sometimes you see a lot of hallucinations you might have seen sometimes when you're dealing with AI. That is the reason why you're seeing hallucinations, is because it's just giving a predictive analysis back to you, especially if it doesn't have concrete evidence to give you. Or it could be many other reasons. It could be, I think sometimes it's just, to me, I call it lazy, because it'll put in like filler stuff, placeholders, stuff like that. Doesn't actually fully do the job. I think that's because of resources in the back end, because you don't see it, but there's a lot of resources being pulled and tapped into at that point. How machine learning works. So talked about it, but the machine learning pipeline starts with raw data collection, followed by data processing, cleaning, and feature extracting. The processed data is used to train the model, which learns patterns and relationships. The trained model can then make predictions on new unseen data, right? So if it's new unseen data, then it's doing predictive analysis and letting you know what that is. But if it's got concrete evidence, a lot of times you can even ask it like, hey, can you give me your source data for all of this? And it'll give you the source data where it received it. It still doesn't mean that it's correct, right? Because that source data could be incorrect too. That does happen. Supervised learning. So learning from labeled training data where each example includes both input features and the correct output. The model learns to map inputs to outputs. Labeled data, training examples with known correct answers. Training model learns patterns from labeled examples, and prediction apply learned patterns to new unseen data. Common application, classification, email spam detection, image recognition, regensen, price prediction, weather forecasting. So it's just like a massive predictive analysis system that on a mass scale it's happening, but also at the same time it's feeding its training models, right? So it's constantly learning and training models, but it's still a massive predictive engine. The law of massive predictions, like basically the law of possibilities, the law of numbers. And when you can crunch, the more data you get, the better at crunching those potential, those possibilities, right? The laws of possibilities. So let's keep going. Unsupervised learning. So learning from unlabeled data by discovering hidden patterns, structures, and relationships without predefined categories or guidance. So clustering groups similar to data points together automatically, dimensionally reduction, simplifying complex data while preserving key information, anomaly detection, so identifying unusual patterns or outliers in data, and use case, so customer segmentation, recommendation systems, data compression. There's always going to be a lot of anomalies. There's always going to be some outliers, and the more data that it can crunch, even if they're unsupervised learning, the fact is that it can still recognize that, which is still, that's a thing these are all things that we do in our own mind, these patterns. We're recognizing patterns, we're distilling, we're crunching numbers in our mind. And our mind has a subconscious that has access to, it's like the superhighway of millions of libraries of the universe, even like the universal library of knowledge that we don't even know where it comes from sometimes, but it's just like our mind tapping into it. This super learning devices now has everybody's mind, has everybody's data sets, has every library, has the world's internet. Basically the internet's its backbone for knowledge, and so it has data sets that are massive for learning. So it's basically like figuring out a way to crunch those numbers in a pattern that was built for it to learn. Reinforcement learning, so learning through trial and error by interacting with the environment. The agents take actions and receives rewards or penalties, learning to maximize cumulative rewards over time. So agent, the learner that makes decisions and takes action. Environment, the world of agent interacts with and learns from and rewards feedback signals that guide learning towards optimal behavior. Use case, game, AI, robotics, automation, autonomous vehicles, resource optimization, and I'm sure the list goes on and on. Deep learning. Deep learning is a specialized subset of machine learning that uses artificial neural networks with multiple layers, deep networks, to automatically learn hierarchical representations of data. Multi-layers, deep networks with many hidden layers beneath input and output. Automatic feature learning, so discovers complex patterns without manual feature engineering. Hierarchical representations, so learns simple features first, then combines them into complex concepts. Applications, large recognition, speech processing, and natural language and understanding. So you can see like deep learning is like these deep neural networks, and that's where they get more hierarchical information, right? So it could be based off of hierarchical needs. So if it's top to the bottom, so like the highest level to the lowest level of information, and it could go deep into the network to find that information if it needs to. That's really important, I think, for our future, because there's these deep libraries of all these doctor studies and theoretical essays and stuff like that. It could get into that deep information to use the large processing of numbers, a large rule of numbers, and figure out really good possibilities, especially in the medical industry. And even further than that, like a lot further than just medical, but I see medical being a really good application for this. Neural networks are computing systems inspired by biological neural networks. They consist of interconnected nodes or neurons and organized in layers that process and transform information. So input layers receive raw data and features. Hidden layers process and extract patterns through weighted connections. Output layers produce final predictions or classifications, and connection weight links that strengthen through learning. Okay, guys, I'm going to stop the video right at this point, and then we're going to go on to the next video. We'll go ahead and continue on this data that we're going through. See you on the next video.